In the last video, we covered recursion, how we can solve the problems, what are the steps of writing a recursion. Let's solve one more problem based on recursion, and we will again revise those concepts which we studied in the last class, right? So in this problem, we have to count the number of zeros present in a number. Okay, so if this is my number, right, 0 0 1 0 2 4, the answer will be 2, right? We will not consider these two zeros which are coming before the number. Like, we know that 0 before the number has no value, so we will just count this and this number, right? So in this case, we will have output as 2. In the next one, we have 7 0 4 0 0 0. We have total 4 zeros, so the output will be 4. A very simple problem, right? To write the recursion, we know that we need a base case, a recursive step, and a small calculation. Okay, base case, recursive step, small calculation. We discussed this in the last video. So let's write the function for this. Since we have to return the count, the return type will be an integer. We have count zeros. Then we will get a number as an input. Okay. We will discuss the base case later. Let's first see what we have as a recursive step. So, like we discussed, that if I have any number in recursive problems, I have to break down this in two parts: the part which I will solve and the part which recursion will solve. So what I'll do, I will tell recursion, okay, count the zeros from the number, but leave the last digit for me. I will check the last digit and will tell you if it is a 0 or not. But you do rest of the part. Okay, so except for the last digit, recursion will check all the digits if it's a 0 or not. Right? So again, we will have our recursive step. So it will be count zeros. We know if we want to separate last digit from rest of the number, to get the rest of the number, we will do n by 10, right? This will give all the digits except for the last digit. So I will give this part to recursion. Okay, and I will assume, right? I will not think how recursion will solve the problem, how recursion will count the zeros. I won't think any of that. I will just assume that this will bring me the answer. Okay, so this will bring me the answer in this variable. So when recursion will be done with this, I will have the answer till this point. Now what I need to do is, I need to check if the last digit is 0, that means whatever the recursion had in answer, I will add 1 to that, right? If recursion got 2 zeros and if my last digit is also 0, that means there are total 3 zeros. So what I'll do, I will return recursion's answer plus 1. That means this plus 1 is for my 0. This is true if the last digit is 0, which I had to check, right? But if it is not 0, that means the answer will be what recursion got, right? So for example, in this case, if you see, the last digit is not 0, right? The last digit is not 0. That means the recursion's answer will be the final answer. So it will return X directly. But if the last digit was 0, then we will add 1 to that because we have an extra 0 apart from the recursion's answer. So we have x equals to count zeros n by 10, n mod 10 equals to 0, and this. So we are done with our recursive step. We are done with our small calculation part. This is done. Now we need to take care of the base case, right? What should be the base case? Now notice that if I write n equals to 0, because eventually if I keep doing divide by 10, my number will be eventually 0, right? If n is 0, if n was 0, right, that means I will have a 1 0, right? If n is 0, that means we have 1 0, so it should return 1. So if I write if n is equals to 0, return 1, right? This seems to be a correct base case, but actually it's not. Okay, actually it's not a correct base case. If n is actually 0, we should return 1. That is completely fine. But just think, this n equals to 0 is not true for the initial case only. What happens is, when you keep dividing your number, suppose you have this number. If you divide this by 10, we will get 1 0 1 2. If you divide this by 10, we will get 1 0 1. You divide this by 10, we will get 1 0. You divide this by 10, we will get 1. You divide this by 10, we will get 0. So if you keep dividing a number by 10 in programming, you eventually get a 0. But the 0 was not actually part of my number. This was a separate 0, right? Only 1 0 was part of my number. But this 0, which I got after dividing 1 by 10, was not part of my number. It became 0. And this is where the problem lies. So our if n is equals to 0 condition will run for this as well. That means it will return 1. So if I run my code for this, the answer will be 2 with this code. Okay, the answer will be 2 because it will count this 0, okay, and it will count the 0 which the number will become later on after dividing by 10. So there are 2 zeros, but actually there is only 1 0 in this number. So this base case is exactly not correct, right? We will have to modify the base case. So instead of going till 0, what I'll say, if I will check if n by 10 is equals to 0. That means I'm checking one case in advance. I'm checking if I divide this number, if this is the last digit, right? I need to check it, right? So if n by 10 is equals to 0, return 0, right? Because the last digit, from the last digit, if I have 1 0 2 4, I can return from here only. I don't need to go further. Okay, if I get 1024, I divide it by 10, I get 102. I divide it by 10, I get 10. I divide it by 10, I get 1. Now at this point only, I will check if this is my last digit or not. If this is my last digit, just return 0 from here, because this is not 0 obviously, right? This will never be 0. So I will return 0 from here. So this will be my base case. Okay. Again, we are passing all the digits except for the last one. We are checking if the last digit is 0, we are adding 1 to the recursion's answer. If it is not 0, we are returning recursion's answer. Right? We are checking on the last digit. If we are already on the last digit, that means we can return 0. Let's try to write the code. I have my main function here. I'm taking input from the user. Okay, let's see. We will create a function count zeros, and we will pass in here. Let's create the function. We'll write our base case. If n divide by 10 is equals 0, we will return 0. So this will take care of my base case. We will have our answer here. We will check if the last digit is 0. We will return the answer with +1. Else we will return the answer from recursion. Okay, let's save it and run it. So we can give our answer as 708000. So we get 4 as our answer, right? So this is how we think of recursive problems. Again, I was not thinking how recursion will solve this problem. I was just concerned about my step. If you solve recursive problems this way, will be much easier.